ABCD is a parallelogram, meaning that its opposite sides are parallel. If A is at 3, -4, B is at 6, 2, and C is at 4, 6, then what are the possible locations of point D? Draw a graph and justify your answer. Well, I've set up a Cartesian coordinate plane, and I've very carefully plotted these 3 points, and I'm being asked to find a fourth point such that the shape I have is a parallelogram. And I think I have a problem because I've been forced to think a certain way, and I don't know that we necessarily need to impose that here. If I look at these points, I could see at least 3 different spots where I could pick a fourth point to get a parallelogram. One of them is, and I'll just kind of maybe put a little spot in here. So one of them would be somewhere like in this region, and you could see you kind of get a parallelogram with those 4, just somewhere in here. Another point that I could get would be somewhere way up, maybe up in here. And so what I'm saying is I would have a parallelogram like this thing, right? And then, well, that looks terrible, but that means I just picked the wrong point somewhere up here. But there's a point up there that exists that would give me a parallelogram. And then, and the same thing with it down in here. And then there's another point that's somewhere over in here that would produce this, this kind of nice looking parallelogram here. Now here's my problem. I've been told that when we write the name of a parallelogram like this, A, B, C, D, those things should be in order, and we shouldn't be jumping around in vertices. So once a pattern is started, you need to complete it. So if they're going, for example, in this case it looks counterclockwise because we're going from A to B to C. That means going around this way, D has to be somewhere in this location. So I'm going to find the coordinates of that D that's in that spot. And if you're thinking about it and you're like, hey, I think there's other spots, I think you're right, and you might want to give me those other spots. And I'll certainly calculate them as well. So if I know that the opposite sides are parallel to each other, I know somewhere, let me just grab the line tool here and draw a couple lines. Somewhere there is another point, somewhere there's another line that's parallel to the line I've just drawn, right? So if I'm thinking about that line, I can move that line left or right so that it's parallel to A. And the best way to find that is to just use this slope pattern, right? If I consider starting at A, I move up 1, 2, 3, 4, and I move backwards to the right, to the left rather, 2 units. Well, if I do the same thing starting at A, I would move up 1, 2, 3, 4, and then I would move back 2, 1, 2, which would place me, did I do the same thing? 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 1, 2, yeah. It would place me right here. So I know that this line AD, if I'm going to call this point D, this segment that I've just drawn AD would certainly be parallel to the one up at the top there, CB. And in fact, if I finish these off, these 4 sides, I think that I have this parallelogram. But it's also nice to kind of verify that the other points, the other sides have the same slope pattern as well. So let me grab a green pen and do this. So if I was to start at A and go to B, I would go up 1, 2, 3, 4, 5, 6, and then I'd move over 1, 2, and 3. So same thing here, I could go up 1, 2, 3, 4, 5, 6, and then I could go over 1, 2, 3, and I landed exactly at B. So there are no more doubts in my mind. I have this definitely a parallelogram, and I've verified that it's a parallelogram by looking at the slopes, right, and writing down, well, I didn't write them down, but I definitely recorded their slope patterns. So this thing is asking me to justify my answer. Well, first of all, what is my answer? I'm saying that D is located at the point 1, 0, x is 1, y is 0. And I could say this creates a parallelogram because let's see, segment A, segment AD and BC both have a slope of, let's see, the slope was up 4, 1, 2, 3, 4, and back 2. So it's a rise of 4 over -2, which is equivalent to a slope of -2. So they're going down 2 units for every unit they go forward. And if you have congruent slopes or equal slopes, you have parallel lines. So they are parallel. And the same is true for AB and DC. Both of those have a slope of 2 in that case. So they are parallel. So what I have here is a quadrilateral with exactly 2 pair of opposite sides being parallel. 2 pairs of parallel sides. So it is not just a quadrilateral, it's special. At least a little special. It's special, it's a parallelogram.